Hi guys, it's Ms. Miner, and this is lesson 5E. And for today's lesson, we are going to continue with our system of equations, and we're going to be comparing two sets of data. Remember, a system just means more than one equation we're comparing. And what's different about today's, though, is this time we're going to take it into a real world application. We're going to kind of have some story problems. We're going to look and see what does a system of equations look like in the real world. Okay, so remember back when we were in Unit 3 and we were just barely starting to talk about equations, setting up these two variable equations, and we talked about, is the movie theater mug worth buying, right? And that's kind of we came up with two equations, and just for purposes of ease and quickness, what I've done is I've kind of rounded some of these numbers up for our equation. So instead of $14.75, I just called this 15. And instead of $1.50, I just called this $2. And then the last one that I rounded up, instead of $4.75, I just called that $5. So I just rounded those up so that we weren't dealing with decimals right now, because I just want to be able to kind of graphically show you what's going on, and then we can talk about what things are representing in the equation. And so when we were talking about this before, we came up with two situations. And the first situation was just, what is the total cost? What are my total dollars if I just pay for a large drink? So this is the total cost of just buying a large drink when I go to the movie theater. And so Y would be my total cost, right? And then $5 because I've rounded that up. So each drink costs $5. And then X would be, how many drinks am I buying? Or how many times do I go to the theater and buy a drink, right? So X represents how many. And if I were to graph this, so X is representing number of drinks, number of large drinks. And Y represents, my Y axis represents my total cost, right? And so we said, all right, well, if I go to the theater and I buy one large drink, my total cost would be $5, right? If I go to the theater 2 times, so now I bought 2 large drinks, my total cost would be $10. If I go to the theater 3 times, that's 3 large drinks, so my total cost would be $15. And if I graph this, I'm going to start down here at 0 because my initial cost would be nothing. If I don't go to the theater and I don't buy any large drinks, right, then there's no charge for that. So if I buy 1 drink, it's $5, 2 drinks was $10, 3 drinks was $15, right? And so on and so forth. And so we can graph this, and we can use our knowledge of graphing now to represent our total cost per drink. And so I'm just going to graph that. Okay. And so if I said, oh, what's the total cost if I buy 10 drinks, right? We can see that it would be $50. So I hope you can kind of see how that works. All right. Okay. Now, again, in my equation, instead of a large drink this time, whatever I've done there, let's kind of move that back. Okay. So instead of a large drink this time, let's talk about the cost if I had so again, Y would be my total cost, X would be my number of refills this time, and 2 is the cost per refill. 15 would be my upfront charge because I have to pay the $15 to get the big mug. So it costs me $15 just to buy the big mug. So if I go to the movie theater and I don't ever refill my mug, I just buy it, right? So this time we're going to create a table of values representing the cost of the big mug. It's $15 if I buy the mug and then don't ever refill it. If I refill it one time, then my total cost is going to be $17. If I refill it 2 times, my total cost is going to be $19. So, and so on and so forth. And so then I can graph the cost for if I buy the big mug, right? So it starts out up here at $15, and then after 1, it's 17. So it's almost 20, right? And then 19. Oh, I probably got let's do this. There we go. And then 19, and then 3 would be 21. So then we're here. And 4, let's kind of get this close, would be 23. Oh yeah, now we're going in the right direction. Now I can kind of see where that line's going. I don't want to do that. I want to get a straight line here. Let's get my straight line going. Switch over to my straight line now and get that going in the right direction. Okay, great. So now we can see this is the line that represents my big mug. And this is the line that represents just buying a large drink every time. And we already kind of talked about this, right? When we were doing it before. And we said, about how many times do I have to go to the movie theater until my big mug cost is the same as the cost for a large drink. And if we're looking at this graph, our place where they are the same is at 5, and over here 25. And so there's the place where those two things are the same. And what we really want to start to understand in this lesson and from these story problems is, what are these numbers? What does this place where they're the same represent? What do those numbers represent? So what does the X value here, the 5 in my ordered pair, what is it representing? Well, I have to know what I'm talking about, right? And in this case, my X values all represent number of large drinks. And then I can say, well, then what does my Y value over here represent? What does this Y value over here represent? And all of my Y values represent cost. And so this is cost. And so when I'm looking at this, I can say, oh, well, the point at which the cost of my movie theater mug becomes like worth it, right, is when I buy five drinks or spend $25 in drinks. That's where those two values become the same. And at that point, right, then we can see graphically, at that point, the large drink cost is now above the big mug cost. And so that's also the point where now the cost of my big mug is less than, right, this place right here, the cost of my big mug down here is less than the cost of my large drinks at that point. And I can see that graphically. All right, so that's kind of what we're talking about, and we're trying to kind of start to figure out what are these X and Y values representing and put them into a context so we can understand when I locate this point where they're the same, what does that mean, right? And in this case, it means, oh, well, that's the point where my big mug becomes worth it to buy. Okay, so this is straight off your homework assignment for today. And so we're just going to do the first problem together because this is where we're going to have to kind of make some predictions as well and start to use our lines to make predictions. And so the first thing we're going to do on our homework today, and you can see this is all Santa, because we're doing this right about Christmas break. And this year we're just a little bit behind. But, okay, so this is how this works. First thing we got to do is we got to come up with some equations from our story problem. And the first scenario says Randall already has 20 toys made, and he makes 5 toys every hour. So I want to write an equation, y equals blank x plus blank for each of these scenarios, and then graph it. So the first two are going to both be graphed on the first graph right here together, and then we're going to compare. Okay, so the first one, Randall has 20 toys already made. So that's his starting amount. So that's going to be his beginning value, B value or y-intercept value. And then he makes 5 toys every hour. And here's this word every right up here. And so that tells us that the 5 is our slope number. Okay, so X is going to represent the total number of hours, and Y is going to represent total number of toys. And there's a couple of different ways we can graph these. The first one is just make a table, right? Set up a table, X and Y, and ask yourself, okay, well, if he starts out with 20 toys and no time has gone by, what about after 1 hour? If he's making 5 toys every hour, then after the first hour, he's going to have 25 toys. After the second hour, he's going to have 30 toys, right? After the third hour, he'll have 35 toys. And then you can just go ahead and graph these points. X is 0, Y is 20, X is 1. And these are just ever so slightly off your graph here. Sorry, it's not quite lined up the way that it should be. But this is going to be my 1. So at 1, I have 25 toys. At 2, I have 30 toys. At 3, I have 35 toys, and so on and so forth. And we can kind of see where this line is going. And I'm going to make this line blue. There we go. Okay. And now we can kind of see where that line's going. I'm going to erase this just so that it's not right in my way. Okay, now, Y equals blank X plus blank. Julie makes, let's make this one be red. Let's do this in a different color. Y equals blank X plus blank. Julie makes 10 toys every hour. Well, here's that word every, right? So that's indicating that 10 is going to be my slope number, but there's not like a starting amount. So my starting amount here is she's starting out with 0 toys made, right? Okay, so then what we want to do is we want to graph this one. Well, I could also graph this one just by using slope. I just have to be careful about my scale and my slope here. And so for the first one, Julie's going to start out with, I apologize. That's not correct. She's going to start out with 0 toys made. So she's going to be down here at 0. And then after the first hour, right, she's going to have 10 toys made. So she's going to go up 10 over 1. But we have to be careful about our scale because 1 in this scale is all the way over 2 boxes. So we have to be careful about our scale on this if we're going to use our slope method, right? So I go up 10 over 1, and then for the next one I would go up 10 more and over 1 more, right? And so I can either use the slope method or the table method, and either one of those methods is perfectly acceptable. So now we can see exactly where our line is going, and we can graph it. And I don't care if you like table method for story problems. Sometimes that's almost even a little bit easier. Okay, so now looking at that graph, the question is, when do Julie and Randall have the same amount of toys? Hopefully what you said is right here, but that's not the answer that we want, right? We want to know exactly when do they have the same amount of toys. That point right there where they're the same is where X is 4 and y is 40. But what do these words mean? Or what do these, not words, but numbers mean in the context? Those numbers mean that at 4 hours, they both have 40 toys. That's where they both have the same, right? At 4 hours, they both have 40 toys. Now, we're going to ask ourselves, we're going to make a prediction, right? Looking at our graph, who is going to have 100 toys first? Well, if I look at my graph, right, after this point right here where they're the same, right, then what happens to my graph? Who starts going above the line? Well, this is Julie. Julie starts having more and more toys after this point, right? Randall kind of slowly moves out in that direction, but she's increasing her amount of toys faster at that point than Randall. And so Julie will have more toys, will have 100 toys first because her line is going to go above at that point. So we can use our graph to actually help us predict what's going to happen in the future. Okay, so that's kind of how that works. On your homework assignment today, you're going to be graphing your lines and then making some comparisons and answering some questions about your graphs. If you have any questions about this, please make sure and email me or Mrs. Zeider. We're happy to help. You're welcome to join us for a Google Meet on Wednesday at 3 p.m. if you need some additional help.